Imagine a world lit by two different suns, where each sun had its own loyal followers. This was the world of electricity over a century ago. It was a kingdom divided into two powerful empires. On one side, you had the Empire of Direct Current, or DC. This was the world built by the famous inventor Thomas Edison. His DC power flowed in one steady direction, lighting up homes and businesses in big cities like New York. It was the first real taste of electric light for many people, and honestly, it felt like magic. Edison's system was like a straight, calm river, reliable and familiar to everyone who used it. His name was known everywhere, and his invention was changing the world one light bulb at a time. On the other side of this kingdom was a newer, more rebellious empire. This was the Empire of Alternating Current, or AC. This type of electricity was championed by two brilliant minds, George Westinghouse, a clever businessman, and Nikola Tesla, a visionary inventor. Their AC power did something different. It danced back and forth, changing its direction many times every second. This constant change allowed it to travel much farther than DC power could. It was like a wild, powerful river that could cross vast distances, bringing light to places that Edison's calm river could never reach. This new idea was exciting, but it was also seen as a threat to the established world of DC power. The competition between these two empires was fierce. It was more than just a business rivalry. It was a battle of ideas, a true war of the currents. Edison argued that his DC system was safe and proven, while he claimed that AC was dangerous and unpredictable. He wanted everyone to believe that his way was the only way forward. Westinghouse and Tesla, however, saw a future where electricity could be sent cheaply and efficiently across the entire country, not just in small city pockets. They believed their AC system held the key to a brighter, more connected world for everyone, not just the wealthy people living in the city centers. The world was watching, waiting to see which empire would win. This division created a strange reality for people living at the time. A home on one street might be powered by Edison's DC, unable to use the new and exciting appliances designed for AC. A factory just a few blocks away might run on Westinghouse's AC, with powerful motors that couldn't operate on the DC grid. It was like having two different languages spoken in the same city. You had to choose which one you wanted to learn, and once you chose, it was very difficult to communicate with the other side. This separation was a huge problem, holding back progress and creating confusion. Something had to change, but no one knew how to unite these two very different worlds of power. To understand this great electrical war, we need to understand the two types of power at its heart. Let's start with direct current, or DC. Think of DC as a river that flows in only one direction. The water moves steadily from its source, always forward, never turning back. This is exactly how DC electricity works. The tiny particles of energy, called electrons, travel in a straight line from the power source through the wires to a light bulb or a motor, and then back to the source. It's a simple, predictable, and constant flow. This was the system that Thomas Edison perfected. It was wonderful for lighting up a small area, like a neighborhood, because it was easy to understand and control over short distances. Now, let's imagine a different kind of river. This river doesn't just flow forward, its current moves back and forth, alternating its direction. This is alternating current, or AC. The electrons in an AC system don't just march in one direction. Instead, they dance in place, moving forward and then backward over and over again very quickly. It might sound strange, but this back and forth dance is incredibly powerful. This was the system that Nikola Tesla championed. The magic of AC is that its energy level, or voltage, can be easily changed. This meant that electricity could be sent over very long wires with very little energy lost along the way. The key difference between them was distance. Edison's DC was like trying to water a giant garden with a short hose. You could water the plants close to the faucet, but the ones far away would get no water at all. DC power faded quickly over distance, so it needed a power plant every mile or so, which was very expensive. Tesla's AC, on the other hand, was like a high-pressure sprinkler system. You could use a special device called a transformer to boost the power to a very high level, send it across the country, and then use another transformer to bring it back down to a safe level for homes. This made it possible to power entire regions from just one big power plant. So the battle lines were drawn. On one side was Thomas Edison, a practical genius who had built a working system that people were already using and loved. He was a famous and trusted figure, and his DC power was the established king. On the other side were Nikola Tesla, a brilliant visionary with ideas that seemed almost magical, and his partner George Westinghouse, who saw the huge business potential of AC. They were the challengers, the revolutionaries who wanted to overthrow the king. They argued that their AC system was the future, a way to bring cheap and abundant electricity to everyone, everywhere. The stage was set for a monumental clash of titans. The world was heavily invested in Thomas Edison's direct current. Imagine that entire cities had already built their roads for only one type of car. Edison's DC was that first car, and the roads were the copper wires running under the streets and through the walls of thousands of buildings. Huge sums of money had been spent to create this infrastructure. Powerful investors, banks, and companies had all put their faith and their fortunes into the DC system. They had built enormous power plants, all designed to produce one thing: steady one-way DC electricity. To them, the idea of tearing all of this out and starting over with a new system was not just expensive, it was unthinkable. Factories and businesses had also adapted to the DC world. They had purchased massive, heavy motors that were designed to run only on direct current. These motors were the engines of industry, powering everything from elevators to manufacturing equipment. A factory owner couldn't simply unplug his DC motor and plug in a new AC one. The power coming into his building was the wrong kind. Switching to AC would mean replacing every single machine, a cost that could bankrupt a company. So even if a factory owner heard about the benefits of AC, he was trapped by the investments he had already made. The DC system was like a deep root that had grown throughout the city's economy. The problem was not just about money, it was also about trust and fear. Thomas Edison was a master of public relations. He launched a campaign to convince people that AC was a deadly force. He publicly demonstrated the dangers of high-voltage AC, trying to paint it as a public menace that was too risky to bring into people's homes. Since people saw Edison as the father of electric light, many believed him. They were comfortable with the DC they knew, and were scared of the AC they didn't understand. This fear became a powerful wall, preventing cities from embracing the new technology, even if it was better in many ways. So when Nikola Tesla arrived with his brilliant ideas for an AC world, he faced a mountain of obstacles. It was not enough to have a better technology. He had to convince a world that had already chosen a different path. The cities were locked into DC. The factories were filled with DC machines, the investors had their money in DC companies, and the public was being told that AC was a killer. It was a classic chicken and egg problem. No one would build AC power lines if there were no AC motors to use them, and no one would buy AC motors if there was no AC power available. Tesla's dream was stuck behind this great invisible wall of wire, money, and fear. At the heart of Tesla's vision was a truly revolutionary invention, the AC induction motor. This motor was a work of pure genius. Unlike DC motors, which needed special connectors called brushes to feed them electricity, Tesla's motor had no brushes. It worked by creating a spinning magnetic field, a kind of invisible whirlpool of energy. A metal rotor placed inside this field would be pulled along by the spinning force, turning with incredible efficiency and power. It was simpler, more reliable, and required far less maintenance than any DC motor. It was the perfect engine for the new age of electricity, ready to power the world's factories and homes. However, this brilliant motor had one major weakness, a problem that had nothing to do with its design. It needed a specific type of fuel to run, alternating current. Tesla's motor was like a beautiful, high-performance race car, but the world was full of gas stations that only sold diesel fuel. The DC power grids that covered the cities could not make his motor spin. They provided a steady, one-way flow of energy, but the induction motor needed the pulsing, back-and-forth rhythm of AC to create its magical, rotating magnetic field. Without an AC power supply, Tesla's incredible invention was little more than a clever museum piece. This created a massive challenge for Tesla and his partner, Westinghouse. They could travel the country showing off the motor's elegant design and superior performance, but factory owners would always ask the same question: where do I get the AC power to run it? The answer was, you can't. To use Tesla's motor, a factory would have to disconnect from Edison's reliable DC grid and invest in its own expensive AC generator. It was a huge risk. They would be cutting themselves off from the main power source of the city to bet on a new, unproven technology. Very few were willing to take that gamble, no matter how amazing the motor seemed. The situation felt like a stalemate. a frustrating standoff that was holding back progress. Tesla knew his AC system was superior for transmitting power over long distances, and that his motor was the best in the world. Yet, the world remained chained to the old DC system because of the massive infrastructure already in place. The cost of replacing everything, every generator, every wire, every machine, was simply too high. Tesla's dream of an electrified world, powered by clean and efficient AC, was blocked. He needed a breakthrough, a new idea that could bridge the gap between the DC present and the AC future he envisioned. One day, standing inside a noisy, humming DC power plant, Nikola Tesla had the moment of insight that would change everything. He was surrounded by the very machines that represented the old way of thinking, the technology that was holding his own inventions back. These were the massive DC generators, the heart of Edison's empire. Other engineers saw them as obstacles, giant metal dinosaurs that needed to be torn out and sent to the scrapyard to make way for new AC generators. They believed the only path forward was one of destruction and replacement, a costly and disruptive war against the old system. But Tesla saw something different. He looked past the noise and the heat, studying the fundamental principles of the machines before him. He watched the massive coils of copper wire spinning inside powerful magnetic fields. He understood with a clarity that no one else had that the electricity born inside every generator is naturally AC. The machine's own spinning motion creates a current that alternates back and forth. To make it DC, Edison's generators used a special device called a commutator, a mechanical switch that flipped the current around, forcing the alternating flow into a single direct path. The DC power Edison sent out was actually a modified, restricted version of the AC created inside. This realization was a lightning bolt of inspiration for Tesla. The solution was not to destroy the old system. The solution was to work with it. He saw that the DC generators were not his enemies. They were his secret allies. They were already making the AC power his motors needed. It was being generated deep inside the machine for just a split second before the commutator chopped it up and turned it into DC. What if, he thought, he could reach into the machine and tap into that original AC power before it was changed? What if he could let the generator do its job of making DC for the city, but also draw off some of that raw AC for his new motors? Instead of proposing a revolution that would tear the world apart, Tesla envisioned an evolution. He decided not to replace the generators, but to modify them. This was a radical shift in thinking. It was a path of cooperation, not conflict. He would build a bridge between the two electrical worlds, allowing them to coexist. He could give people the AC power they needed for his new motors without forcing them to abandon the DC power they relied on for their lights. He rushed back to his laboratory, his mind buzzing with the elegant simplicity of the idea. He would not tear down the old house, he would simply add a new door. Tesla's plan was as elegant as it was brilliant. He would perform a kind of delicate surgery on the existing DC generators. To understand his modification, let's first think about how a generator works. Imagine a spinning wheel with loops of wire on it, rotating between the north and south poles of a magnet. As the wire loops spin through the magnetic field, they create an electric current. Because each loop moves first past the North Pole and then the South Pole, the current it creates naturally flows one way, then the other. This is the birth of alternating current, or AC. The generator is naturally an AC machine. Edison's generators took this natural AC and forced it to become DC. They used a device called a commutator, which was essentially a ring of metal bars at the end of the spinning shaft. Carbon brushes would press against this spinning ring, and as the ring turned, the commutator would act like a rapid switch, always reversing the connection just as the current was about to change direction. This process, called rectification, straightened out the alternating flow into a single, direct current. So the AC was made inside the coils, but only DC was allowed to leave the machine through the brushes. This was the standard design in every power plant. Tesla's genius was to add a second, much simpler connection to the generator. He proposed adding two smooth metal rings, known as slip rings, to the same spinning shaft that held the commutator. He would then connect these new rings directly to the generator's internal wire coils, tapping into the electricity before it ever reached the commutator. While the commutator was busy chopping up the AC to make DC for the city's lights, these simple slip rings would let the pure, unaltered AC flow out through a separate set of wires. It was like adding a second faucet to a pipe, one that lets out sparkling water while the other faucet has a filter that provides still water. The modification itself was surprisingly straightforward. It did not require rebuilding the entire generator from scratch. A skilled mechanic could open the machine and attach the new slip rings and brushes to the central rotating shaft. This meant that a single generator, one machine spinning in a power plant, could now produce both types of electricity at the same time. From one set of terminals, the steady DC power would flow out to power the existing city grid. From the other set of terminals, the pulsing AC power would flow out, ready to run Tesla's revolutionary new motors. He had designed a bridge, not a battering ram. The day of the first test was filled with a nervous electric energy that matched the currents Tesla hoped to control. In his workshop, a standard, commercially built DC generator stood ready. It was a machine built by his rivals, a symbol of the old world. A small crowd of engineers and potential investors gathered, their faces a mixture of skepticism and curiosity. They had been told that this ordinary DC machine was about to do something impossible: produce both AC and DC power simultaneously. To them, it was like saying a person could speak two completely different languages at the exact same time, with the same mouth. The air was thick with doubt. Tesla, calm and focused, began the demonstration. He started the steam engine that turned the generator's shaft. The machine hummed to life, its commutator and brushes delivering a steady flow of direct current, just as it was designed to do. He connected a bank of incandescent light bulbs to the DC terminals, and they immediately glowed with a bright, unwavering light. "This," he announced, "is the power you know, the power of Edison." He showed the meters, proving it was pure DC. This was familiar territory for the audience. But then came the moment of truth. He pointed to the other side of the machine, to the new slip rings he had installed. With a quiet confidence, Tesla connected a second set of wires to the AC terminals. These wires ran to one of his new induction motors, which sat silently on a nearby workbench. The instant the connection was made, a low hum came from the motor. It began to spin, slowly at first, then faster and faster, until it was running at full speed with a smooth, powerful whir. On one side of the generator, the DC bulbs continued to shine brightly. On the other, the AC motor spun with incredible efficiency. Both worlds were alive at the same time from the same source. A wave of astonishment washed over the room. They were witnessing the end of the war of the currents. This invention was Tesla's masterstroke. It was more than just a clever piece of engineering. It was a profound act of unity. He had not forced the world to choose between AC and DC. Instead, he had created a way for them to work together. Power plants could now add his simple modification to their existing generators and supply AC to new factories without abandoning their DC customers. This peaceful transition allowed the AC system to grow naturally alongside the old one. Tesla's legacy is not just in the technology that powers our world today, but in the wisdom of his approach. He taught us that true progress often comes not from destroying the old, but from building a bridge that connects it to the future. His genius gave us not just power, but a lesson in adaptation and harmony that continues to inspire us.